Chapter 8, Part 3. First, let's start by reviewing how to factor quadratic expressions using a diamond and a box. So for letter A, we have 2x squared plus 5x plus 3. Remember that to factor means to break it down into the things we multiply to get that expression. So with this trinomial, we're going to break it down into the product of two binomials. To figure out what those are, we'll use a generic rectangle. We put our first term in the lower left-hand corner, last term in the upper right. We use a diamond problem to help us figure out these two blank spots, because we know that the diagonals will have the same product. So this diagonal has a product of 6x squared. We know that the missing or blank diagonal also has to have a product of 6x squared. The sum is the term here in the middle. So we know that these two boxes have to add up or combine to be 5x when we're done. So we think about the down problem. We want to multiply to 6x squared, but add to 5x. So you want 3x and 2x. 3x times 2x is 6x squared. 3x plus 2x is 5x. So we factor out each row. So 3x and 3 are both divisible by 3. 2x squared and 2x are both divisible by 2x. 3x and 2x squared are both divisible by x. 3 and 2x are both divisible by 1. So our factors are 2x and x plus 1. Now we double check ourselves to make sure. 3 times x is 3x, 2x times x is 2x squared, 3 times 1 is 3, 2x times 1 is 2x, and so we have 2x squared plus 5x plus 3, which is equal to the original statement. So we'll do the same thing for the second example here. We'll set up our generic rectangle. We'll put the first term in the lower left-hand corner, last term in the upper right. We'll set up our diamond problem. So the product of this diagonal is negative 7x squared. So we know that the missing diagonal would have to have that same product. So our sum comes from here. It's the 5x. And so we're thinking to ourselves, what would multiply to negative 7 but add to 5? Well, to multiply to negative 7, you could have 1 times negative 7. But 1 plus negative 7 equals negative 6, which is not positive 5. Or we could do negative 1 positive 7, but negative 1 plus 7 gives us positive 6, which isn't 5. Since 7 is prime, its only factors are 1 and 7. So these are our only options, which means we can't solve the diamond problem. So this one is not possible. We can't factor it. Most quadratic expressions are written in the form ax squared plus bx plus c. But what do we do if a term is missing? Let's take a look. So letter A, 9x squared, take away 4. We're missing this bx term. So we're going to put in a placeholder. We're going to fill it in with a 0x. Because 0x is really just 0, and adding 0 wouldn't change the value. So I haven't actually changed my expression. I'm just putting something in there to hold the place of the bx. So now I'm going to factor like normal. I'm going to set up my generic rectangle. First term in the lower left-hand corner. Last term in the upper right. Diamond problem. Well, the product of this diagonal is negative 36x squared. And the sum is going to be that placeholder we filled in, the 0x. So I'm thinking to myself, okay, what two numbers would multiply to negative 36 but add to 0? Well, I know in order to add to 0, numbers must be opposites, meaning I must have one positive and one negative. And they'd have to be the same number. So now I'm thinking, what number times itself is 36? That's 6. So you want positive 6x and negative 6x. So that 6x times negative 6x is negative 36x squared. 6x plus negative 6x is 0x. So you fill in your generic rectangle. Your top row, 6x and negative 4. Well, they're both even numbers, so we know they're both divisible by 2. 9x squared and negative 6x are both divisible by 3, and they have an x. 6x and 9x squared are both divisible by 3, and they have an x. And negative 4 and negative 6x are both negative, and they're both evens, so they're divisible by 2. So the factored form of this polynomial is 3x plus 2 times 3x minus 2. On the next one, we notice that we're missing the c term. So we could fill it with a plus 0, but we could also notice that they have a GCF, a greatest common factor, and so we could factor this with a single row box. (12x squared and negative 16x are both divisible by 4, and they both have an x. So if we undo the distributive property and pull out the 4x, we're thinking to ourselves, 4x times what gets you 12x squared? The answer is 3x. And then you're thinking 4x times what? So 4x times what gives you negative 16x? The answer is negative 4. So that 3x times 4x is 12x squared. Negative 4 times 4x is negative 16x. So in factored form, we have 4x times 3x minus 4. Letter C is very similar. This time we're missing the ax squared. So we're going to think greatest common factor in order to factor this. So again, we're going to put it in a single row box. We've got 40, negative 100m. Well, they're both divisible by 10. I know that because they end in 0. But if we go even larger, they're both even, which means they're divisible by 2 as well. So we can factor a 20 out. 20 times what gives me 40? The answer is 2. 20 times what gives me negative 100m? The answer is negative 5m. So 20 times 2 is 40, negative 5m times 2, negative 5m times 20 is negative 100m. So this factors into 20 times 2 minus 5m. Under D, we have all three parts. We've got the quadratic, the ax squared, the linear, the bx, and the constant, the c. So we're going to factor this one like normal. We'll set up our generic rectangle. Fill in our first term and our last term. Set up our diamond problem. So the product here is 24k squared. And the sum is going to be this middle term, which is negative 10k. So now I'm thinking, alright, what would multiply to 24 but add to negative 10? Well, I know they both have to be negative in order to multiply to a positive but add to a negative. So then I'm thinking, what two numbers multiply to 24 but add to 10? Well, how about 4k and 6k? Negative 4 times negative 6 is positive 24. negative 4, plus negative 6 is negative 10. So now we factor out every row. Negative 4k and 3 are both divisible by 1. We don't have any other common factors. Remember, 1 is always your fallback. 8k squared and negative 6k, they're both even, so they're both divisible by 2, and they both have a k. Negative 4k and 8k squared, both divisible by 4, and they have a k. 3 and negative 6k, both divisible by 3. So now I just have to deal with the signs because I have negatives here and here. So I need to fill in negatives here and here. So that 4k times 2k is 8k squared. 4k times negative 1 is negative 4k. Negative 3 times 2k is negative 6k. And negative 3 times negative 1 gives you positive 3. So this factors into 4k minus 3 times 2k minus 1. Now turn your attention to the quadratic below. Sometimes we have to do multiple types of factoring in order to completely factor a problem and for everyone to agree upon the answer. So when we look at this, 4x squared minus 10x minus 6, what we see is they have a greatest common factor. These are all even numbers. They can all be divided by 2. So that's the first thing we want to do is factor out the 2. 2 times what gets us 4x squared? It's 2x squared. 2 times what is negative 10x? It's negative 5x. 2 times what is negative 6? It's negative 3. So that's so far we factored this into 2 times 2x squared minus 5x minus 3. And now we can focus on factoring this. I'm going to do the diamond in a box on this part of it. The 2 is just going to hang out there. So I can say equals 2 times some binomials that I have to find. So we set up our generic rectangle. We have 2x squared minus 3. Set up our diamond problem. Well, the product of this diagonal is negative 6x squared. The sum is negative 5x. So what multiplies to negative 6 but adds to negative 5? Well, if we're going to multiply to a negative, we have to have a negative times a positive. If we had 2 negatives, it would cancel out to be a positive when we multiplied. So we need 1 negative, 1 positive. What 2 numbers would multiply to negative 6 but add to negative 5? We want negative 6x positive 1x. And now we factor every row. Negative 6x and negative 3 are both divisible by negative 3. 2x squared and 1x are both divisible by x. Negative 6x and 2x squared are both even, so they're divisible by 2, and they both have an x. Negative 3 and 1x are both divisible by 1. So it factored into 2x plus 1 times x minus 3. So we have our GCF of 2 out front. And then we have the factors 2x plus 1 times x minus 3. So problem 27, factoring completely. Note that each term in 12t squared minus 10t plus 2 is divisible by 2. That is, it has a greatest common factor of 2. So we can factor the 2 out and write it as 2 times 6t squared minus 5t plus 1. An expression is considered completely factored if none of the factors can be factored anymore. We must remove common factors first before factoring with the generic rectangle. So here's another example. 10x squared plus 25x minus 15. So the first thing we have to notice is that they are all multiples of 5. So 5 times what gives you 10x squared? 2x squared. 5 times what gives you 25x? 5x. And 5 times what gives you negative 15? Negative 3. So that's so far we know it factors into 5 times 2x squared plus 5x minus 3. And now I attempt to factor this trinomial with my generic rectangle and diamond problem. So first term and last term, their product is negative 6x squared. So that's the product of the diamond problem. I need the two blank spots in the generic rectangle to combine to be 5x, so that's your sum. So similar to the last one, I want to multiply to negative 6x squared, but add to 5x. I know I need one positive, one negative. This time I want the 5x to be positive, so I want positive 6x and negative 1x. So that 6 times negative 1 is negative 6. 6 plus negative 1 gives us the negative 5. So we fill that in, and we factor out every row. So 6x and negative 3 are both multiples of 3, so I can divide them by 3 and factor out a 3. 2x squared and negative 1x both have an x. 6x and 2x squared are both even, so they're divisible by 2, and they both have an x. Negative 3 and negative 1x are both divisible by negative 1. So our completely factored form is 5 times 2x minus 1 times x plus 3. So here are two more examples. 2x squared and negative 50. First thing we notice is 2x squared and negative 50 are both even. So we can factor out a 2. So we start with a single row box and pull out the 2. 2 times what is 2x squared? It's x squared. 2 times what is negative 50? It's negative 25. So we have 2 times x squared minus 25. That's missing that bx, so we're going to fill it in with a 0x. And continue to factor. So we'll fill in our first term and our last term. Set up our diamond problem. So this diagonal has a product of negative 25x squared. The sum is that placeholder we filled in of 0x. So we're going to multiply to a negative. We need one positive, one negative. And if they're going to add to 0, they have to be opposites, meaning same number, opposite signs. So we want 5x and negative 5x. Because 5 times 5 is 25. Positive 5x times negative 5x gives us negative 25x squared. 5x plus negative 5x is 0x. So we fill those in. We factor out every row and every column. And we see that our completely factored form is 2 times x plus 5 times x minus 5. So when you're asked to factor a problem, the first thing you want to do is look at all three terms, or all two terms, however many they give you. If they're all divisible by something, if they have a common factor, you have to start by factoring that out. So you put them in a single row box. You identify the common factor. In this case, they all have a y. And you pull that out. And then you think about, okay, that times what gives you that. And that times what gives you that. And that times what gives you that. so that we've pulled out or factored out our greatest common factor, y times x squared minus 3x minus 10, and then you think about factoring this. So you set up your generic rectangle and your diamond problem, put your first term in, your last term, their product goes here, the sum is this middle term, so it goes in the bottom here. So you want to multiply to negative 10x squared, but add to negative 3x. Well, if you're going to multiply to a negative, you need one positive, one negative. Things I know that multiply to 10 are 5 and 2, or 10 and 1. Well, if I try 5 and 2, I get close, but 5x plus negative 2x would be positive 3x, and I want negative 3x. So I need the bigger number to be negative, and the smaller number to be positive, so that when I combine them, I get a negative. So I fill those two that I just found into my generic rectangle, and I factor out every row and column. So 2x and negative 10 are both even, meaning they're both divisible by 2. X squared and negative 5x both have an x. X squared and 2x both have an x. Negative 10 and negative 5x both divisible by negative 5. So we pulled out our GCF of y, we can't drop that, and then we have the x plus 2 times the x minus 5. That is completely factored. So to recap the process of factoring quadratic expressions, you place the x squared and the constant terms in the opposite corners of a generic rectangle. You determine the sum and the product of the two remaining corners. The sum is simply the x term, the middle term, and the quadratic expression. So that's what goes down here. The product is equal to the product of your first and last term. So find the product of this diagonal, and that's what goes here. Then you solve the diamond problem and fill those in the missing spots in the generic rectangle. Factor out every row and every column, and then write out your final answer. Standard form of a quadratic is ax squared plus bx plus c. So we start in standard form, and then we use this process to get it into factored form.